Welcome to Ask and Learn.
In the same way limits are key in single variable calculus, we see that they're also very important in multivariable calculus. Because what we see here is when we have the limit as x, y, z approaches the origin 0, 0, 0 of this function, xy plus yz squared plus xz squared over x squared plus y squared plus z to the fourth, we are dealing with these multiple variables. So we can thankfully simplify this a little bit more because we know that x equals y and x equals z squared. So with that knowledge, what we're allowed to do now is plug in those different values, and what we'd end up getting as a result is going to be the limit as x, y, z approaches 0, 0, 0, and that would be x squared plus x squared plus x squared over x squared plus x squared plus x squared. This is just going to cancel, leaving us with 1, so the limit of it is just going to equal 1. That is the final answer. And then if we were to do something else where x equals 0 and y equals 0, what we'd end up having is the limit as x, y, z approaches 0, 0, 0. And when we plug in those values, we would end up having just the value of 0. We would have 0 over z to the fourth, and that's just 0. And then lastly, one more time, if we have the limit as x, y, z approaches 0, 0, 0 without modifying the value of x and y, what we'd end up getting is that this limit is not going to exist. And the reason for that is the function has two different limits along the two different curves, so the limit will not exist. So while these two limits exist, they're not equal to each other, so this limit does not exist.